All right, so we're going to be starting chapter 19, which really follows nicely after the chapter on circuits. So we're going to be building on the idea of circuits from chapter 19, and we're going to get into those really classic equations. And now the nice thing is you won't just have them and think, oh, these have come out of nowhere. You'll have some idea of where they're coming from. So we're going to be looking at circuits with capacitors. And this has a lot of practical applications. So let's say we've got a circuit, we've got a battery plus, minus, minus, plus. We've got two batteries, we've got a light bulb, and a capacitor right here. So we would expect that you'd have some positive charge here, making that nice positive charge gradient, negative on this side, with the electric field going in that direction. Okay, so we're going to use our ideas of electric field and charge distribution to understand what happens when we have a capacitor in a circuit. And we know what a capacitor is. We've been looking at these for a while. So when we have our circuit with the capacitor, and we hook it up, and we've got a light bulb. By the way, that's a symbol for a light bulb. What is going to happen immediately? All right, so immediately the batteries are going to run current through. Your capacitor doesn't have charge on it at this point, so you're going to see that you're going to get some negative charges accumulating on one plate, some positive charges on the other, and the bulb, so immediate after connection. This works a lot better when I can do demos. The bulb lights up. So if you've done the capacitor lab, you've seen that. So even though the current isn't going through the plate, still the bulb lights up. And so as I demoed in class, after time, the bulb dims and goes out. All right, so now you have a circuit with a bulb and it's all hooked up, but there is no light. But we could make this bulb go on again, and we could do this if we take our capacitor and then we just hook it up independently to the bulb. And what you'd see is the bulb lights once again brightly and then slowly dims and goes out. So bulb lights and slowly dims and goes out. Okay. And this is happening because the capacitor was charged in the first setup, and the current stopped when it was fully charged. And that's because you would then have a positive plate and a negative plate repelling incoming charges. And then in the second setup, the capacitor discharged. So, in both of these circuits, there are two time scales. So the first is the light comes on, which takes nanoseconds. And the second is the light goes out, and this is a time factor we can perceive. And in the process of it going out, we have a quasi steady state. So it's acting kind of like a steady state, but it is slowly changing. That's why we see that slow dimming. So current is slowly changing. As the circuit goes to equilibrium. All right, so before we analyze the circuit a little bit further, let me tell you how capacitors are actually made. So they're not really just two plates. That's impractical. Realistically, capacitors that we're used in circuits typically consist of two strips of metal foil separated by an insulator. So that capacitor that we studied with the insulator inside, that's actually pretty realistic. So there is no path conducting through the capacitor. So in other words, current is not flowing through the capacitor. So charges don't jump from one plate to another. And we need to keep this in mind as we're thinking about the physics behind this. Okay, so now that we understand where all this is coming from, let's start analyzing these situations in more detail. So we're going to start with the discharging of the capacitor. Okay, so we're starting out, this capacitor is charged. So we've got our light bulb in our circuit. And let's walk through exactly what's happening, looking at the fields and the charge distributions. So after we've hooked it up, we would have maybe this side of the capacitor is negative, and this side is positive. And then we would have our electric field. That would come from these two plates. And this would be driving the electrons around. So the electrons are basically just redistributing themselves, trying to get to equilibrium. All right, so at about 0.01 seconds after connection, the bulb glows. And there's a big gradient across the filament. And the electrons are flowing through. Oops. And these will move opposite the field. All right, so what's happening on the plates of the capacitor? So they started out being fully charged, and now we're moving stuff around. So essentially, if we think about our little circuit here, the electrons move off the negative plate. And so if this is our negative plate, it's going to start to lose electrons as they start to move around the circuit. And then the negative plate loses charge. And then these electrons go around depositing themselves on the positive plate. And then the positive plate gains electrons and loses charge. And so you start to get a smaller electric field as a result. And when you have a smaller field, you have less current. And then more time passes. These plates lose more and more charge, and eventually you have I is equal to 0, E is equal to 0, and darkness. The bulb has gone out. And this is, of course, a gradual process. I mean, we can observe it within a time span that makes sense to us. All right, so now that we have looked at what happens when we discharge the capacitor, let's look at what happens when we charge the capacitor. So here, plus, minus, minus, plus, our bulb, and the capacitor. Okay, so here we have a circuit that has just been connected with the capacitor and the batteries. And so we're going to step through again what's going to happen. So immediately, the light is going to go on. So the bulb burns just like a regular circuit. And the capacitor is uncharged. Now, the flowing charges have consequences. So what we'll have is that so you'll have this become more positive, diluting the charge, making this plate positive. And so the running current will pull electrons causing part of the wire to become more positive. And then the electric field decreases. And the bulb dims. So essentially, you start out, you've got some dilution of charge here, and then this battery and this battery, they're pulling the electrons through. And so as it's pulling the electrons out of this part of the wire, it becomes positive, and this is becoming negative, and then this plate is becoming negative, and this plate is becoming positive. And then more time passes, and we get our final state. which is that you have no current and you have a fully charged capacitor. So we have reached equilibrium. And we have darkness again. And so the capacitor is now charged up. So the initial field takes nanoseconds to establish. And the arrival of equilibrium takes seconds. And it's a slow enough change to be called quasi-steady state. All right, so we'll finish 19.1 in the next video.